Yeah, we do, we're the changes.
Right, guys. So as I was telling you guys, this section we just did as well as this section, I could have probably done it in one day instead of two. So today and tomorrow, today's not too bad. And today and tomorrow will be kind of short because I split it into two. Okay. So today, what we are going to talk about is finding the area of trapezoids and rhombi. And then I believe we get into the kites tomorrow. Okay, so first of all, a trapezoid. I believe we talked about trapezoids last trimester. Okay, do you guys remember how trapezoids have like two bases? And we did different things where we found angles of trapezoids. We also found what's called the mid segment or the median of it. And in this section, what we're doing is finding the area. And the area of a trapezoid is 1/2 times height times our two bases added together. Now that cheat sheet that I gave you guys yesterday or the day before would have the formulas on there, so you don't have to know them. But basically, the height has to be perpendicular again. It has to be at a right angle. And then the two bases, it doesn't matter which one you call B1 and which one you call B2. Okay. So if I look here, again, this is the formula, and your height has to be perpendicular. Okay, if it's not, you can't use it as a height. So in this one, they call the top one B1. That's just your first base. This one is your second base. Your height is perpendicular. And sometimes it'll happen again where they put the height outside of the trapezoid. So just so you're aware of that. So if I look at this one here, they're asking us to find the area. And notice here, it's just kind of a trapezoid on its side, but this is my height, okay? And then these two would be my bases. So I could maybe call this one B1 and that one B2 or vice versa. Okay, it doesn't matter which one you call which. So all we would have to do here is go 1/2 times the height, which is 11, times our two bases added together, which is 15 plus 7.5. Now, if you're somebody who wanted to type that into your calculator all in one, you could go 0.5 times 11 parentheses 15 plus 7.5 parentheses, or you could do add those two together. 15 plus 7.5 is 22.5, and then just type that into your calculator. And when you go 0.5 times 11 times 22.5, you should get 123.75, and that is in square inches. Okay. All right, when we look at this next one, again, they just drop that perpendicular height outside, and that's fine. So this is your height. I could call this my B1 and this my B2, and then it's a matter of just putting it into my formula. I'd go 1/2 times, my height is 5, and I'd add my two bases together 31 plus 16. Okay, so again, you could use parentheses and type that in as it looks, or you could think of what is 31 plus 16, and that's 47, and then you'd go 0.5 times 5 times 47, which I got 117.5, and that is in square meters. So notice in this one, we're not having to find the perimeter at all. We just have to find the area. So this is another one that has its trapezoid on its side, but the nice thing is that we don't really have to do any like trig to find a missing side or anything like that in this section. So, or on this side. So B1 is this, B2 is this, and then I would just plug that in. So I could go 0.5 for the half, height is 28, and add the two bases, which is 12 plus 24. So I would like you guys to write out this line and then the answer, okay? So when you do that, again, you could add those two together and get 36. Or you could type it into your calculator exactly how it looks up here with parentheses. And I got, is it 50.4 or 504? 504? Okay, thank you. And that's yards squared. Okay. Now, if we go down to this one here, notice in this one, this is our like B1. This is my height. And notice this little distance right here is 5. This little distance is 5. Could I find this distance? What do you think this distance would be? Wouldn't it be what that is, right? 20.5, okay? All right, so if you found this whole distance, it would be 5 plus 20.5 plus 5, which if you don't like fractions, just change it to decimals. But 5 plus 20.5 plus 5 is 30.5. And that could be my B2. And then here is my height. And again, you could change 38 1/4 to 38.25. Okay, so let's go over here. Our height is 38.25. One of our bases is 20.5. And one of our bases is 30.5. Okay, so now what I would do is either add these two together and then type it in, or like we've said, you could put parentheses and do it that way. Did you guys get 975.38? All right. And that is in square feet. So if we go here, this says Miguel designed a deck shaped like the trapezoid shown below. Find the area of the deck. So remember, when you do this, you need to find the two bases and you know the perpendicular height. Do you guys get this is the perpendicular height? So I know that. And I know one of my bases, but I don't know this. Okay, so what we could do to find that is we could make a right triangle right here, where this is 5. If that's 4, do you guys get that's 4? And then I could find this distance right here. Does anyone know? This is something I definitely want you guys to know when you leave here, is what is the most common right triangle? What 4, 5? 3, okay? The reason for that is, you guys, when you guys take your ACT, it's timed. I don't know if you knew that. It's, I don't even know the exact time, but you have to do like 60 questions, maybe in 45 minutes. So you have to be really good and go fast. And if you sat and did Pythagorean theorem for a problem, like say they just gave you this, you know, that's taking up time. Whereas if you just look at this and go, yep, 3, 4, 5, that's my answer, and just skip on to the next, That's going to give you more time on the harder ones. So this is 3. Okay, now think about this. If this is 3, what would this have to be for the whole thing to be 9? 6, right? And if this is 6, do you guys get this would be 6? So that's kind of a lot of work to find what that top base is. And then what I would do is do area is 1/2 height times B1 plus B2. If you want to just use 0.5 for the half, you certainly can. The height is 4. First base is 6. Second base is the whole thing, which is the 9. And if you type that in, you are going to get 30, I believe. Yes. So that's 30 square feet. Okay. And if we go down here, the next thing that we're going to do is just talk super quick about the difference between a rhombus and a kite. And honestly, with you guys, I'm not sure if I taught kites, but for what you have to know, it's fine. Do you guys remember learning about kites? I think I skipped kites to get through the material. But if you guys look at this, what happens with a rhombus is all 4 sides are equal. And then with a kite, like I said, I'm not quite sure if I talked about this or not with you guys, but these 2 sides would be congruent always, and these 2 would be congruent. So there's always 2 consecutive sides that are congruent in a kite on each side. Okay. The big thing about rhombi and kites is that you have to know their diagonals. So when we're doing area of either a kite or a rhombus, you have to know the lengths of their diagonals. Okay. So if we go to the next page, this gives us the formula. It does not matter if they give you a rhombus or a kite. This is the formula. And like I said, you guys have a cheat sheet that has your formulas on it. You don't have to worry about memorizing them. So if I go here, the area, and really honestly, you don't worry too much about, is it a kite? Is it a rhombus? But this one obviously is not where all 4 sides are equal. So this is a kite. So it'd be 1/2 D1, D2. Okay. And then we'd go 1/2. One of the diagonals is 7. One of the diagonals is 12. Okay. And then easy, you just do 0.5 times 7 times 12, which did you get 42? No. Oh, yeah, sorry. 42 square feet. Okay. If we look at this one, now one of the things you have to know in a rhombus, and this was something we learned about a parallelogram, a rhombus, a rectangle, and a square, is that the diagonals bisect each other. So these 2 pieces are always going to be equal, as well as these 2. So if this is 7, this is 7. If that's 9, that's 9. So you absolutely have to know that. So area is 1/2 or 0.5 D1, D2. The 1/2 is 0.5. The first diagonal, just take one of them and add the 2 pieces. 9 plus 9 is 18. The second diagonal, 7 plus 7 is 14. Okay. And then you would just type that in. And I got 126 square inches. Okay. Now, if I look at this one, again, area is 1/2 D1, D2. So you would just, this is a kite, and notice in a kite, these two can be equal, they don't have to be, but like these two wouldn't be equal, okay? So the diagonals don't cut each other in half in a kite. So here, what I would do is go 1/2 or 0.5. One of my diagonals is 20 plus 20, and the other one is 26 plus 56, which is going to be 82. And when you do that, you should get 1,640 square inches. Okay. So this one, what you would have to realize is that it's a rhombus. And so when it's a rhombus like that, you would have to be able to know that these two pieces are equal. So if this is 2, this is 2. And if this is 5, this is 5. Okay. So then I'd go area is 1/2 D1, D2. One of the diagonals is 2 plus 2, which is 4. The other diagonal is 5 plus 5, which is 10. So that should give you 20, and that is in centimeters squared. Okay. So then your assignment is, so I'm going to give you guys a worksheet, and you're going to do this on the worksheet, this in the book, and then staple your book assignment to the worksheet. Okay. So I will hand out your worksheet. Oh, by the way, this worksheet, actually, let me think about this. Why don't you turn in the book assignment today? And then tomorrow you'll do the rest of this worksheet. We'll turn that in separate. And then we'll have a book assignment tomorrow. We'll turn that in separate. So you'll have 3 separate 10-point assignments. Does that make sense? Yeah. And it and if you think this is too easy, I can tell you it does get harder. But you're bored, a little bit harder. But you have a quiz on just sections 1, 2, and 3. And that shouldn't be too bad. You guys should do well on that, I would think. 10-4 and 10-6, we do them, and those are harder.